So Michael addition is the reaction between an enolate and an alpha beta unsaturated carbonyl compound to give 1,5-dicarbonyl compound. Let's draw a scheme for the reaction in general. So this is the ketone in general, again with an alpha hydrogen. If the ketone is treated initially, let's say, with LDA, of course LDA should convert the ketone into the corresponding enolate. The enolate, being very versatile now, can be reacted with an alpha beta unsaturated carbonyl compound. Conjugate addition takes place, or 1,4 addition. If the intermediate enolate that's formed as a result of the conjugate addition is treated with H3O+, then 1,5-dicarbonyl compound is obtained. So this is 1,5-diketone, 1,5-dicarbonyl compound. You can number these carbons. So this is a very distinct structural feature of the product of the Michael addition. Now, we now recognize that an enolate is required, and of course an alpha beta unsaturated carbonyl compound is required as an electrophile. But these are not the only nucleophile electrophile that can be used. Now, if the enolate is used, therefore, of course, being nucleophilic, it can be described as Michael donor. It's a Michael donor, a substance or a species that can donate electrons and thus nucleophilic. So an enolate, therefore, is Michael donor. So any enolate, basically, so Michael donor, basically an enolate, something like this in general. And of course here in this type, or when we speak of Michael donors, any compound that can give an enolate can act as Michael donor. So basically we talk about carbonyl compounds in general. We also talk about 1,3-dicarbonyl compounds such as 1,3-diketone, beta-ketoesters. Okay, these very special and unique compounds, 1,3-diketones, beta-ketoesters, dialkyl malonates. Those are excellent Michael donors. That's because, of course, that methylene position flanked by the 2 carbonyl compounds is very, very acidic. The pKa range between 9 and 13, if you recall. So Michael donors, therefore, basically any carbonyl compound, we can also add to them 1,3-diketones. We can also take beta ketoesters like that. We can also have dialkyl malonates as excellent Michael donors. Of course, when we write the structure of the enolate, it's implied, okay, that any carbonyl compound that can make an enolate can be used to give a Michael donor. So Michael donor is basically an enolate or any carbonyl compound that can give an enolate. And of course, these are excellent or ideal substrates for Michael donor, 1,3-diketones, beta-ketoesters, and dialkyl malonates. Not only we can have Michael donors, of course, we can have also Michael acceptor. Actually, the alpha beta unsaturated carbonyl compound is Michael acceptor. So what's required in Michael acceptor is a double bond between alpha and beta carbons, and of course a multiple bond nearby. So this does not actually have to be a carbonyl compound. We could have an ester, of course, we could have a ketone, we could have any carbonyl compound that's alpha beta unsaturated. But not only that, we could have alpha beta unsaturated nitroalkenes. We can have alpha beta unsaturated nitriles. So something like, for Michael acceptors, so something like ketones, that's possible. Esters, for example, typically, those are also possible. We can have amides, of course, that are substituted on nitrogen. We could have alpha beta unsaturated nitrile, something like that. Alpha beta unsaturated alkanes. Of course, they are nitroalkenes, they would be. So again, all of these are alpha beta unsaturated. And if you recall, in the nitro group, of course, this is an excellent Michael acceptor, because the nitro group, of course, as you recall, is an electron withdrawing group by resonance. There is a multiple bond. Obviously, there is a double bond between nitrogen and one of these oxygens, so that will act as an electron withdrawing group. Therefore, these compounds are excellent substrates to function as Michael acceptors. So what's required is actually a double bond between two carbons, alpha and beta carbons, and of course a multiple bond between an atom and an electronegative atom. Nitrogen and oxygen in this case, carbon and nitrogen, triple bond in that case, and of course carbon and oxygen in all of the other carbonyl compounds. So these are examples of Michael acceptors. These are examples of Michael donors. In the Michael addition reaction again, or the Michael reaction again, an enolate reacts with an alpha beta unsaturated carbonyl compound, or we can now generalize it to be alpha beta unsaturated compound in general, to give overall 1,5 dicarbonyl compound.